The purpose of this video is to review the various forms of an equation for a line and talk about how we can use a couple of them to solve linear programming problems. First, that everybody knows is slope-intercept, y equals m times x plus b. M is the slope, b is the y-intercept, x is the x variable, y is the y variable. The next one is point-slope form. This is the form of an equation of a line when we're given a slope and a point. So it's y minus y1 equals slope times in parentheses x minus x1. x1, y1 are going to be actual numbers, and the x, x1, y1 is the point that you're given, m is the slope that you're given. The third form is the standard form a times x plus b times y equals c, which is a constant. Then the one you've probably never heard of before is intercept-intercept form. That's x divided by the x-intercept plus y divided by the y-intercept equals 1 always. If we start with a standard form equation of a line, x plus y equals 30, and divide both sides by 30, we get x over 30 plus y over 30 equals 1. So my x-intercept is 30, my y-intercept is 30. And that's not useful in a TI-84 calculator, so we'll go over getting a standard form of an equation for a line into slope-intercept. So from here, I need to get y by itself. So I'm just going to subtract x from both sides, and I get y equals 30 minus x. That's not really in slope-intercept form, so I'm going to swap the x and the 30, and it's really a negative x. And then if I explicitly put the negative 1 times x in, I get y equals negative 1 times x plus 30. So negative 1 is the slope, and y is the y-intercept. Now, if I want to graph that on a piece of graph paper, okay, so pretend this is right along that line. Now I'm going to go put in my tick marks. I'm going to go with 5, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, 30. I know that my y-intercept is 30 and my x-intercept is 30. Then it's really good to have a straight edge when you're doing these problems. So all I have to do is put a straight edge between those 2 points, draw my line in, and I've got a perfect line. Now, the other 2 things I have are x has to be greater than or equal to 5, and then y has to be greater than or equal to 9. And I'm going to put the little arrows, so greater than or equal to, greater than or equal to, and then the 30, my max capacity for the, well, then drawing this line, I'm kind of jumping ahead to the problem, but the max capacity of the plane is 30, so we're going to go less than or equal to that. So we've got the graphs done there for the problem that I haven't read to you yet. So now I'm going to show you how to graph this in the calculator. I'm going to put in the roughly slope-intercept form. Oh, I don't see anything. Well, that's not a problem. I just don't have a good window. I'm stopping at 6 2/3 here and at 10 here. So I'm going to go to menu for 1, and I'm going to go negative 10 to 40 for x, and I'm putting a little bit of extra room out past 30. Then negative 10 to 40 for y, and actually let's put the tick marks every 5. So I've got my graph there. So menu, I'm tracing here, putting in 0. So my y-intercept indeed is 30. And my x-intercept is 30. And then we're going to go do one of the problems in the problem set. Air Charleston sells business class tickets and tourist class ticket seats for its charter flights to the Bahamas. To charter a plane, at least 5 business class tickets must be sold. In addition, at least 9 tourist class tickets must be sold. The plane does not hold more than 30 passengers. Air Charleston makes $40 profit for each business class ticket sold and $45 profit for each tourist class ticket sold. In order for Air Charleston to maximize its profits, how many tourist class seats should they sell? So I'm going to do what the rubric says to do. So we'll put problem 1. And the first thing is identify the variables. We're going to make X is business class tickets and Y equals tourist tickets. Then the second thing is identify the constraints. So we know that the business has to be greater than or equal to 5. Tourist has to be greater than or equal to 9. And then the capacity of the airplane is 30. So business tickets sold plus tourist tickets sold has to be less than or equal to 30. And then we're going to do the objective function, which in this case is profit as a function of X and Y, is going to be 40 times the business class ticket sold plus 45 times the tourist ticket sold. And then 4 is the graph, which we've done on another place. So here's our graph. So the vertical line here is X equals 5. This horizontal line is Y, or Y is greater than or equal to 9. So this is our feasible region. So we know that the equation of this line is Y equals 30 minus X. So if I'm at X equals 5, 30 minus X, or 30 minus 5 is 25. So this point is 5, 25. That's a vertical line, so that's 5. This is a horizontal line at 9, so this point is 5, 9. This one's a little bit tricky, but we know that this Y is 9. So if I substitute in 9 equals 30 minus X, I'm now solving for X. I'm going to move the X over and make it positive. 30 minus 9 is 21. So this point is 21, 9. And our rubric says to identify the vertices. So we'll put that 5. So our vertices are going clockwise from the bottom left, 5, 9, and 5, 25, and then 21, 9. Then we're supposed to maximize. So our profit as a function of 5 and 9 is 40 times 5 plus 45 times 9. Oh, yeah, 5. This is 6. So maximize. And I'll go ahead and do that in the calculator. I'm going to start a calculator page. And then we're going to do 40 times 5 plus 45 times 9. So I get $605 for that first intersection point. Then profit at 525 is going to be 40 times 5 plus 45 times 25. Calculator again, and I can grab that and edit that. So 25, so that gives me 1325. And profit at 21, 9, 40 times 21 plus 9, or 45 times 9. So we're going to go grab that calculation again. We're going to make business class seats 21. and change tourist seats to just 9, and we get 1245. And then the last thing we're kind of supposed to do is answer the question. The question was, how many tourist class seats should they sell? So they should sell 25 tourist seats. Okay, so that concludes this video, and I'll go back and do another problem showing specifically how to do the graphing.